Welcome all. In today's video, we will be talking about Varactor diodes. So, Varactor diodes are nothing but variable capacitor diodes. As we have seen in case of a PN junction diode, the IV characteristics looks like this. Okay, generally, if it is a normal diode, the reverse current that will go quite high after the breakdown. So, a PN junction diode can be used as a capacitor because especially in reverse direction, if you are applying a reverse voltage V in this range, okay, there is a quite large range over which if you apply a reverse voltage, the current is not going to change, right? So this current is not going to change. This is almost like reverse saturation current IS, and that's why generally these vector diodes are used in reverse bias. Okay, so this side minus and this side plus. And the junction capacitance in case of abrupt junction, if the doping profile is something like this, right? So Na minus Nd around the junction, then we had derived in our class that the junction capacitance is given by this equation. So generally this Cj is proportional to 1 by root over Vbi plus Vr, right? If you do the same calculation for a linearly graded junction like this, so Na minus Nd is equal to some constant, let's say C or alpha into X. If it goes like this, then Cj will be proportional to 1 by, sorry, yeah. So that will be 1 by Vbi plus Vr to the power 1 by 3. Okay, here you have 1 by Vbi plus Vr to the power 1 by 2. In general, if you have a junction profile which is given as any junction profile, okay, so let's say you take it like this, okay, where this junction profile is proportional to x square, right? Na minus Nd. So if the junction profile Na minus Nd, if it is given as x to the power m, then the junction capacitance is proportional to Vr to the power minus n, where n is equal to 1 by m plus 2. This is a general derivation. If you go through various books, you will find it. So in case of when m is equal to 0, okay, so for abrupt junction, you can see that these are constant, right? So these are constant. So m is equal to 0. This implies that n is equal to, from this equation, n is equal to 1 by 2, and hence C is proportional to, or junction capacitance, reverse bias junction capacitance is proportional to Vr to the power minus 1 by 2. You can see. So likewise for a linearly graded junction, m is equal to 1. This implies that n is equal to, from this equation, 1 by 3. This implies that the junction capacitance that will be proportional to VR to the power minus 1 by 3, as in this case, right? We can use any one of them because here we have Cj, which is a function of reverse bias voltage. With reverse bias, because the capacitance is changing, and hence if we use any LC circuit, then the resonance frequency that is dependent on L and C, right? Omega R is equal to 1 by root over LC, right? And hence omega R can be a function of VR. So we can change the resonance frequency just by applying voltage over here. So here actually this capacitor will be actually a diode or Varactor diode. What is the advantage? Because the capacitors, they don't have any current, so this I is almost like very small, and that could be achieved without changing anything in case of a reverse bias junction. However, these are not called the Varactor diodes. The abrupt junction or linearly graded junction, they are not used. They are not used as a Varactor diode. Even though you can technically, by definition, the capacitance is dependent on VR, right? VR to the power 1 by 2 for this abrupt junction, and VR minus 1 by 3 for linearly graded junction. However, these devices are not used for as a Varactor diodes. What we want is that in our practical applications, that we want something like this, that if we change the VR, the resonant frequency should be linearly related. So that will be quite good for applications. So that we should know that if at VR naught, if we have a resonant frequency of, let's say, 1 gigahertz, okay, or 100 megahertz, then after a slight amount, so VR plus some delta, we will have this frequency. So that will be clearly predefined. So calibrations are very easy, right? And that is why there is a special junction which is called hyper abrupt junction, which is used to find it linearly. That means if we want that Cj should be proportional to, from this equation, if you see, for omega r to be proportional to Vr, we must have Cr proportional to Vr to the power minus 3, sorry, minus 2, right? This implies that n is equal to 2, and this implies that m is equal to, or you can say that is equal to 1 by m plus 2, and hence people found that if we can have m is equal to minus 3 by 2, right? So if it is minus 3 by 2, that will become 1 by 2, so 2, right? So m is equal to minus 3 by 2, that is a profile which will give you omega r proportional to VR. So that is a back calculated, right? Back you can calculate. So you want a resonant frequency proportional to VR, and hence from this equation you can say that C should be junction capacitance, that should be proportional to VR to the minus 2, and hence we know that in generally in a junction capacitance is dependent on voltage profile like this, where M is the junction profile. M is the junction profile. Right, so this is of a special case which is called hyper abrupt junction, and these junction profiles are used in case of Varactor diodes. So these junctions, if you see, so that would look like this. So this is nothing but if this profile Na minus Nd is equal to some constant alpha into x to the power minus 3 by 2. Okay, that means 1 by x root x. Right? Yeah. So if this is the doping profile, generally, practically it is not achieved like this, but generally it is very high concentration at the junction, middle of the junction at x is equal to 0, and then it decreases. Instead of increasing the uh, doping concentration, it decreases. It has highest dose at this. Practically, you cannot achieve this because ultimately this line will be something like this. This line will go cross 0 over here somewhere, and the line will look like this. These are the abrupt junctions, Varactor diodes, and these diodes can be used as a, sorry, not visible. Okay, so these diodes can be used in reverse bias in place of this capacitor C. So here you will find Cj over here. The notation for Varactor diodes are like this. Okay, so these are the Varactor diodes. So we should use this line, right? How to change the applied potential over here? Applied potential can be changed just by using a knob or potentiometer. Let's assume we have 5 volts over here, ground over here. So just by using a potentiometer, just with knob, actually this position can be changed up or down, right? And the applied voltage that can vary from 0 to 5 volts, right? So this will become as a, this will work as a capacitor. Now this element can be used anywhere in your circuit. Okay, so this is the capacitor or variable capacitor. I think I have covered this topic. You can have Varactor diodes with different profiles also, but this hyper abrupt junction, they are the most suited for application, and people have already using it. They are already using it. Okay? So thanks for this. Next lecture I will discuss the transient behavior of a transistor. Sorry, transient behavior, transient behavior and reverse recovery time of PN junction. Thanks for your time.